Hi everyone, welcome back to Chem Help ASAP. In this video, we are going to convert complex units. Let me explain. If you're like me and you live in the US, speed limits are given in miles per hour. This is a complex unit. It has a unit in the numerator, miles, and also a unit in the denominator, per hour. But what if you were driving in another country and you needed to convert miles per hour to kilometers per hour, or vice versa? What if you needed to take miles per hour and convert it into meters per second? Well, hang on to your calculators because we're going to do exactly that.
Okay, let's take a look at our first problem for converting complex units. So the problem reads, a ball rolling down a hill travels at 85 meters per second. How fast is the ball moving in kilometers per second? Okay, so first let's identify this as a complex unit. We have meters divided by seconds. That's what makes this a complex unit. We have two units to deal with. And we want to convert, and we're still going to keep this complex unit. So again, we have kilometers now divided by seconds. So what I am seeing just for my roadmap is I need to take meters to kilometers, but I don't need to do anything with the denominator. So seconds stays the same. So it looks like this is going to be a pretty simple conversion from meters to kilometers. But let's actually do the math. Starting with what I'm given, 85 meters per second. Now, I do want to point out that I have written this in a different way than the problem gave it to me. These are the same thing. We don't usually write the 1 when we say meters per second. We don't usually say meters per 1 second. But when there is no number specified for the denominator, we always assume it is 1. Writing 85 meters per second in this way is going to help you keep track of what's going on with the denominator separate from what's going on with the numerator. So I definitely recommend when you're doing your conversions, write your complex units as a fraction. Okay, again, I need to convert this meters into kilometers. Of course, that is just a metric to metric conversion using our prefixes. Again, if you need a review on metric to metric conversions, you can check out this video here in the upper right. Here is my conversion factor. There are 1,000 meters in 1 kilometer. So let's cancel our units. My meters have canceled. And now you can see I have kilometers, and I've just left the seconds alone. They still remain in the denominator. They're just kind of hanging out. Now let's grab our calculator and do our math. I'm going to take 85 and I'm going to divide by 1,000. Here is my final answer, 0.085 kilometers per 1 second. But if you prefer, you can also write it like this. Again, that's still 0.085 kilometers per second. Okay, let's do another problem. When a car is moving at 90 kilometers per hour, how fast is it going in kilometers per second? Okay, again, complex units. I have a unit in the numerator and the denominator. This time it looks like my kilometers are staying the same, so my numerator is staying the same and my denominator is changing. So I'm going to need to convert hours to seconds. Starting with what we're given, 90 kilometers per hour. Again, notice I write it as a fraction and I put it per 1 hour instead of writing it like this because it makes very clear that this unit is in the denominator. Okay, so I need to take this hour to seconds. I'm actually going to do this in 2 steps. You can do it in 1, but I'm going to show it in 2. So first I'm going to take this hour into minutes. Here is my conversion factor. Of course, there are 60 minutes in 1 hour. Now, the key thing here is you notice your hour is in the denominator. So my hour here must be in the numerator. Again, you want units to cancel. So my hour cancels. I know often the first time you see this kind of cancellation, it feels weird because we're used to doing this kind of cancellation up here in our first problem where we cancel numerator by putting it in the denominator. But remember, when you're changing up the unit in the denominator, you need to cancel, which means it needs to be in the numerator in your conversion factor. Okay, so now I have converted my hours into minutes, but of course the problem asked me for seconds. So I have one more conversion factor. Here we go. There are 60 seconds in 1 minute. Again, I have the minutes in the numerator because I want it to cancel with the minutes in the denominator. So my minutes cancel, And now you can see I have seconds left in the denominator, which is exactly what I wanted. My kilometers, again, it just hangs out because I don't need to convert it to anything because it stayed the same from the problem here to what it was asking. Okay, so I'm going to grab my calculator. I'm going to take 90, divide it by 60, and then divide that by 60 again. And I get 0.0250 kilometers per second. So in both of these first problems, we either had to just convert the numerator, like in the first problem, or just convert the denominator, as in the second problem. So let's do some more conversions where we're going to have to deal with both the numerator and the denominator. This problem reads, chemical energy is often measured in joules per gram. A certain fuel has a chemical energy of 32.6 joules per gram. What is this energy measured in joules per kilogram and then in kilojoules per kilogram? So we've got a couple conversions to do here. Now, don't worry if you don't understand what chemical energy is, or maybe you don't know what joules are. That's totally fine, because all we're going to be doing is using prefixes to convert this. This, again, is part of the beauty of the metric system. You don't have to know what a joule is to convert it into like a kilojoule, because you know kilo means 1,000. Okay, so let's do the first part of this problem. We want to convert this energy to joules per kilogram. So we're starting with joules per gram, and we're going to joules per kilogram. So my joules are hanging out. I don't have to do anything with them. My gram, though, is changing to kilogram. So again, this is a pretty simple conversion. I'm just converting the denominator. Let's start with what we're given, 32.6 joules per 1 gram. Again, notice it's going to be helpful to write this like a fraction. I need to convert this gram into kilograms. Here's my conversion factor. There are 1,000 grams in 1 kilogram. Notice my grams cancel, and now I'm left with kilograms in the denominator, which is exactly what the problem asked me for. Okay, so I'm going to grab my calculator. I'm going to put 32.6 in. I'm going to multiply by 1,000. And I get 3.26 times 10 to the 4th joules per kilogram. Okay, let's do the second part of this problem. We need to convert to kilojoules per kilogram. So this is where we're going to have to convert joules to kilojoules and also grams to kilograms. Now you could start with this number right here where you've already converted to kilograms. That is perfectly fine. To show that this is a two-step process, however, I'm going to start with my original number, my 32.6 joules per 1 gram. But no matter if you start with the original number or the number that you just calculated, we will get to the same place. So just like before, I'm going to work with my denominator first. I'm going to convert these grams into kilograms. So here is my conversion factor. Just like before, my grams cancel, and now I've converted into kilograms. Now I need to convert my numerator. So I'm going back to my original problem. This joules needs to be converted into kilojoules. Again, don't worry if you don't know what a joule is. All you need to understand is the prefix kilo, like in a kilogram. So here is my conversion factor. There are 1,000 joules in 1 kilojoule. Now notice how this cancels. At this point, we're used to canceling from this conversion step, but notice my joules are actually going to cancel with my original number. This is why I wanted to show it in 2 steps. So my joules cancel, and now I'm left with kilojoules. So if I look at this calculation, I can see that a lot of my units here have canceled. What units still remain? Well, in the numerator, kilojoules remain, and in the denominator, kilograms remain. And that is exactly what I want, because I want this in kilojoules per kilogram. Now you can think about this math in 2 ways. You can grab your calculator, you can take 32.6, you can multiply by 1,000 and then divide by 1,000, or you can see that 1,000 divided by 1,000 is just 1, which means our answer is 32.6 kilojoules per kilogram. Again, it doesn't matter if you do this on your calculator or you just recognize that 1,000 over 1,000 is 1, you are going to get to the same place. Let's do a few more problems. This problem reads, when electroplating copper, the rate copper was deposited in the electrode was measured to be 5.94 grams of copper per minute. What is this rate in pounds per second? And there are 28.35 grams in 1 ounce and 16 ounces in 1 pound. So this part right here is just helping us by giving us a couple of conversion factors that we may not know. Don't worry if you know nothing about electroplating, or maybe you know nothing about copper. What does this mean that this is a rate? You just want to focus on the units. This is a conversion. So I'm going to start with what I'm given, 5.94 grams of copper per 1 minute. Now, just to be clear where I got that from the problem. You can see the 5.94 grams of copper per minute. Now, it didn't necessarily specify per 1 minute, but when we don't specify the number, then it is assumed to be 1. Because if it is 2, you would put a per 2 minutes up here. Okay, so we're going to take this grams of copper per 1 minute, and we've got to convert it to pounds per second. So I've got to convert the grams to pounds and the minutes to seconds. So I'm converting both the numerator and the denominator. Now, it doesn't matter which one you convert first, the numerator or the denominator, because they're both going to get converted. I'm going to start with the numerator, but if you would like to start with the denominator, please feel free. Go ahead and start with the denominator. I'm going to use the problem's conversion factor here, that there are 28.35 grams in 1 ounce. So here is my conversion factor. Of course, I'm going to set it up so my grams of copper cancel and I'm left with ounces of copper. Okay, so now that I have ounces of copper, of course I want to go to pounds, so I have one more conversion factor. And the problem also helpfully told me that there are 16 ounces in 1 pound. So I'm going to use that conversion factor right here. Again, making sure that my ounces of copper cancel, and now I'm left with pounds of copper. So at this point, I have pounds of copper per 1 minute. So I'm close, but I'm not quite there because I want pounds per second. So I still need to take this minute and convert it into seconds. So here's my final conversion factor. Now remember, this minute is going to cancel with the minute in our original number way back here. Let's take a look at our calculation and see what units are left. So again, the grams and the minutes are gone. Ounces and grams are gone. I have pounds still left in the numerator. That's good. That's what I want. And then in the denominator, I have seconds. That's good. That's also what I want. So I have converted everything I need to convert. I just now need to grab my calculator. So I'm going to take 5.94 divided by 28.35, divide that by 16, and then divide that by 60. My final answer is 2.18 times 10 to the negative fourth pounds of copper per second. I do want to point out for this calculation, we did not have to know what electroplating was. You didn't even have to be sure of what copper was. You just had to know your conversion factors between all of your units. Let's do one more problem. A car is driving at 72 miles per hour. What is the speed in kilometers per second? And then we're given a conversion factor that there are 1,609.3 meters in 1 mile. So that's really helpful. It's always tough when we're converting in between imperial and metric. Metric is very easy with the prefixes, but imperial, those conversion factors sometimes are known and sometimes are not known. Okay, so I'm going to have to take miles to kilometers, and then in my denominator, I'm going to have to take hours to seconds. I'm going to start with what I was given, 72 miles per 1 hour. So this time, just to mix things up a little bit, I think I'll convert my denominator first. Again, it doesn't matter. Choose whichever one you like. I need to go from hours to seconds. Again, I will do this in 2 steps, but you can also do this in 1 step. Here is my conversion factor to minutes. There are 60 minutes in 1 hour. Make sure my units cancel. So my hours have canceled, and now I'm left with minutes. Of course, I need to take my minutes to seconds. So here is my next conversion factor. There are 60 seconds in 1 minute. Making sure my units cancel here. So now my denominator is in seconds, which is exactly where I want it to be. Okay, so now let's deal with the numerator. I have to take these miles and convert to kilometers. This conversion factor right here is going to be really handy. I think I'm going to use it first. Okay, here is my problem's conversion factor. Again, there are 1,609.3 meters in 1 mile. Make sure your units cancel. So my miles cancel with my miles back here in my original problem. So don't forget to go all the way back here to cancel. Okay, so at this point, I've gone from miles to meters, but my problem has asked me for kilometers. So I have one more step. Here is my final conversion factor. There are 1,000 meters in 1 kilometer. Let's make sure units cancel. So you can see meters cancel with meters. Now I'm left with kilometers. Just like we did with the other problems, let's make sure that the units that are left in this calculation are the units that I want. So all of these have canceled. Oh, here's seconds in the denominator. Yes, that is what I want. And then I have kilometers in the numerator. And yes, that is also what I want. So my conversion is complete. Now let's grab a calculator. I'm going to take 72 divided by 60. Then I'm going to divide that by 60. Then multiply by 1,609.3. And then divide by 1,000. My final answer is 0.032 kilometers per second. So the trick with these is making sure you keep track of your units, where they are, how they're canceling, and when you're done with your calculation, make sure your units end up where you want them to be.
Converting these complex units becomes much more manageable when you can see how you can take it step by step. Now, please though, if you are driving, do not convert miles per hour to kilometers per hour. Give that task to a passenger after you explain how to do it. Now, if you want to see how to do other conversions, you can check out these videos here, and thanks so much for watching.